So in number 5, according to Ohm's law, the voltage is equal to the product of current and resistance. So we want to find the rate of change in resistance when both the voltage and current changes in this problem. Yes, so let me copy this. So let's first differentiate this equation. That means dv over dt is equal to, we are going to use product rule. So current is differentiated first, and then resistance is also differentiated, and they are multiplied in the product rule. I mean, they are added. Mm, and then from the problem, dv over dt is 1. It's increasing. And for the current, it's decreasing. And because it's decreasing, the sign is negative, and 1/3. Yep, so that's the answer for A and B. dv over dt is 1, and di over dt is minus 1/3. And then the C, we make this equation by differentiation. And then in D, and now let's put the some values. So when voltage is 12 and current is 2 ampere, using this law, if V is 12 and I is 2, what's the value of R? What's the value of resistance? Can you hear me? Can you solve this equation? Yeah. It's 6. So a resistance in this case is 6 ohms. And then if we put these values to this differentiated equation, dv over dt is 1, R is 6, di over dt is minus 1/3. Current is 2 ampere. Yep, so when we solve this equation, we'll be able to find the rate of change in resistance. So, can you find this value, dr over dt, by solving this? Yep. Also add 2 to both this equation, both the sides, and then divide it by 2. Yeah, 3 over 2. So is it increasing or decreasing? Uh, Increasing, because the sign is positive. And how can I say? In this situation, I mean, voltage is increasing. Usually, if resistance is constant, when voltage is increasing, the current will be also increasing. But in this situation, uh, when the voltage is increasing, the current is decreasing. So that means the resistance is increasing. So that's the situation. So that's why dr over dt is increasing in this case. And then let's think about this electrical power. It's related to the previous problem. So electrical power is the product of voltage and current. And if we change voltage to the IR of previous equation, and we get the equation for electrical power equal to resistance times current squared. So if we differentiate this equation, dp over dt is equal to, once again, we are going to use product rule. Yep, we have this equation by differentiation. Mm, and then we want to find this dr over dt, and once again, the rate of change in the resistance. If p is constant, if p is constant means that this dp over dt is 0. And then let's move this the first term to the left. So so we can cancel one I and divide. Yep, so this is the relationship between the dr over dt and di over dt. And let's change this r to p because p is constant. That means p r is equal to p over I squared. So yep, we have this equation, and this means um, so because of this negative sign, if current is increasing, the resistance will be decreasing. The direction is opposite because the product of resistance and I squared is constant. Maybe I can say uh, when the electrical power is transferred through the electrical wire from the power generator to our home or our house and factory, during such transfer, some power is lost, and to decrease such a loss of power, uh, we can decrease the resistance. And am I right? Yeah, yeah. Resistance. Yeah. Uh, yeah. Let's talk about it later. I mean, it's too hard to explain. Yeah. So going back to math, let's look at number 13. This ladder is sliding down. And we want to find the rate of change in the angle between the ladder and the horizontal surface in this problem. Yeah. And the length of the ladder is 13 feet. Mm. So we can first make the equation using Pythagorean theorem. So x and y, because these make right triangle. When we have this equation and the base is moving at the rate of 5 feet per sec, this means dx over dt is 5. So for the first equation, when you differentiate this Pythagorean theorem, this becomes 0. So we can cancel these 2's. And at this moment, base is 12. So when x value is 12, what's the value of y when x is 12? Using Pythagorean theorem. Can you find the value of y? Yep. Yep. So yeah, 5. Yeah, 5. Y value is 5. So we can use this value in this equation. So when x is 12 and dx over dt is 5 and y value is 5. So can you find the dy over dt in this equation? You can cancel 5. So that means dy over dt is when you move 12 to the right side, it becomes negative. So dy over the top of the ladder is sliding down with the rate of minus 12 feet per, with the rate of 12 feet per sec. The sign is negative because it's going down. That's the answer for first equation. And how about the area? Okay. So for the area is the product of x and y. So if we want to find the rate of change in the area, uh, so dA over dt we want to find. So using product rule, so y is 5, dx over dt is 5, x is 12, but dy over dt is minus 12. Yep, can you find this value? Make the square and subtract in this case. Yep, 5 squared minus 12 squared is, yeah, minus 119, alright. Yep. So square feet per sec. That's the rate of change in the area of this triangle. So because of this minus sign, we can see that the triangle area is decreasing. Hmm. Okay. And then finally, let's look at this rate of change in the angle. That means So from the triangle, cosine theta is uh, x over 13. So if we differentiate this equation, do you know what's the derivative of cosine theta? Deri yeah, derivative of cosine is minus sine theta. Yep. So if we differentiate this equation and then sine theta. So in this right triangle, when y is 5 and x is 12, what's the value of sine theta in this triangle? Yeah, sine theta opposite of hypotenuse. Yeah, if theta is here, opposite is here. Yeah. Oh yeah, tell me the fraction. I mean, yeah. Yeah, 5 over 13. Hypotenuse is 13. So this sine theta is minus 5 over 13. And dx over dt is 5. So what is going on here? Okay, let me. Yeah, so we can cancel everything. So that means d theta over dt is minus 1. The unit is radian per sec. So once again, because it's minus minus, the angle is decreasing. And in number 15, when a girl flies a kite, she needs to let the string loose to keep flying, the kite flying. So let's make a triangle. Mm, and the height of the kite is constant, 300 feet. And the kite speed, the horizontal speed is 25%. Uh, okay. So let's say this is x and the length of the string is L. So this means the horizontal change in distance is 25. And once again, we can make the Pythagorean theorem. So if we differentiate this equation, And then at this instance, uh, the kite is 500 feet away from a girl, so the L is 500. Okay, so when L is 500, what's the value of X when you use Pythagorean theorem? 400. So if we use these values, X is 400, dx over dt is 25, L is 500. Yep, so what will be the value of dl over dt when you solve this equation? Yeah, 20, 20. Yeah, 20. Yep, so the she needs to let the string loose at the rate of 23%. And when the sand pile is growing, hmm. So the conical pile is the property is height is 38 of the diameter, base diameter. So we can make the equation. Height is 38 of diameter, and because diameter is 2 times radius, that means height is 34th of the radius. And the volume of the cone is this. Let's first find the radius, the rate of radius. So if we change h to 34th times r, 3 cancel. And if we differentiate this equation, dv over dt is, so what is the derivative of r cubed? Yeah, can you find the derivative of r cubed? Yeah, okay, r cubed. You're right, 3r squared and dr over dt. And then dv over dt is 10 in this problem. And then height is 4. Okay, so when h is 4, when h is 4, what's the value of r when you solve this equation? R is 4, so r is 16 over 3. Yep, so if we use this, okay, so dv over dt is 10, r squared is, so we can cancel. So dr over dt is 15 over 32 times pi, and this is a meter per sec. So if we want to change this to centimeter, we need to multiply 100 here. Can you find this value using calculator? Yep, yep. Divide. Oh, you don't have a calculator? Okay, so let me do this here. So, so 1500. Yeah, over 14.92 centimeter per minute. The radius become bigger because sand is piling. And how about the height? Because we have the equation with height and radius. If we differentiate this equation, dh over dt is 3/4 of dr over dt. And so that means we are going to multiply the 3/4 to this the dr over dt. So if we do that, here we can multiply 30 over 4. Okay, so the height grows at the rate of 11.19 centimeter per minute. What is going on here? Something is not right. Number 18. In this case, draining means it's decreasing. The volume is decreasing. Once again, the reservoir has a conical shape, vertex down. So at first, the dv over dt is minus 50 because it's going out of the reservoir. And then the ratio between the radius and height is 5 over n6. So r over h is 45 over 6. So when you simplify this, like this, and then water is 5 meter deep, so h is 5. Okay, so when h is 5, what's the value of radius in this ratio when h is 5? Yeah, when h is 5. Tell me the fraction. Okay, so yeah, 5 times this one, so 75 over 2. That's the radius. And then once again, the volume, the cone's volume is, we have this equation, so dv over dt. Okay. Uh, yep. So let's change r to h, because r is this. Yep. Let's first change. Oh, so r squared is like this. R squared, this squared. Yeah. Okay. So if we differentiate this equation, dv over dt is, hmm, uh, yep, and then this dv over dt is minus 50. H, wow, why is it so 25? Okay. So dh over dt is, yep, this is the rate of the level, because the negative means the level is decreasing because water is going out. And for the radius, because we have the relationship between radius and height, r is, so that means dr over dt is, so if we multiply this, minus 225 upon, yep, so radius is also decreasing, because the volume gets smaller. Okay, and it changes centimeter per minute. So if we want to change this to centimeter, we need to multiply 100. So that's about, yep, so it's about 8.49. We can say minus because it's decreasing. once again, the volume and the water is draining, but in this case, the shape of the reservoir is spherical and not conical. So we have a little more complicated equation for the volume. Yeah, so if we use this equation for the volume, volume is if we open the parenthesis, and in this problem, the radius is 13. The large r is 13. So that means yeah. So that means so when the water is 8 meter deep, that means this y value is 8, and so that means uh, from the center to the water surface, it's 5 meter. So can you find this small r, a value of this small r using Pythagorean theorem? Oh yeah, can you find this value? Yeah. 13 and 5, so that means, yep, yep, yep. hmm So at this instance, yep, our value of the small r is 12, and then we want in problem A, we wanna find dy over dt. Okay, yep. So let's differentiate this equation. So dv over dt is so I think we can use some factoring here. And in the problem, the dy over dt is -6, and value of y is 8. dy over dt is am I right? Yeah. Sorry. 1 over 24 pi. Like this. Yep, and because of this negative sign, the water level is decreasing. And for problem B, if we want to find the radius, radius is 12. No. In this case, if we generalize the process, so this is 13 minus y. So if we use Pythagorean theorem in this triangle, so if we simplify this equation, so if we take the square root, r is the square root of 20. Y times 26 minus y, we get this expression. And then if we want to find the radius change, okay, so let's differentiate this equation, and that means so we can cancel 2, and so when y is 8, r is 12, s- so this means the radius change is 5 over 12 times dy over dt. And we know this dy over dt minus 1 over 24 pi. So yeah, this is the rate of change in radius of a water surface. Yeah. A unit is a meter per sec. And in number 20, when raindrop grows, the rate of volume is proportional to the surface area. So if we make the equation in this situation, dv over dt is proportional to the surface area. Let's say surface area is A, and so the volume of the sphere is 4 over 3 times pi r cubed, and the surface area of the sphere is 4 pi r squared. So if we differentiate this volume equation, dv over dt is so we can change this 4 pi r squared to a, and because the dv over dt is equal to k times the surface area, we can also cancel a. So that's why the rate of change in the radius is constant in this situation. And in number 22, when the rope draws a boat to the post, the height of the post is 6 feet constant, and the howling means the length of the rope is decreasing. So if we make the Pythagorean equation in this right triangle, so if we differentiate this equation, yeah, the howling rate is 2 feet per sec, so that dl over dt is minus 2. And we want to find this dx over dt. Okay, so when the length of the rope is 10 feet, using Pythagorean theorem, what's the horizontal distance? What's the value of x? Can you find value of x in this right triangle? Yep, 6 and 10. So what's the length? Yep, 8. Yep. So we can use these values. So x is a dx over dt. L is 10. dl over dt is minus 2. Yep, so can you find dx over dt in this equation? Yep, multiply 10 yeah, you're right. Minus 5 over 2. This minus means, the x value is decreasing, so that's the meaning of this approaching. So we can just say 5 over 2. It's a 2.5 feet per sec because it already says it's approaching. It already says the direction. And then a theta, value of a theta. Yeah, so cosine theta is, which one should is better? Let's use a tangent. Oh, yeah, let's use tangent. So in this triangle, tangent theta is x over 6. Mm. Yep, if we differentiate this equation, do you know the derivative of tangent theta? And tangent theta's derivative is a secant squared. Mm. And we know dx over dt is minus 5 over 2. So if we use the value, so d theta over dt is equal to, because secant is 1 over cosine, it becomes cosine when it goes to another side. And cosine theta in this triangle is 6 over 10, 3 over 5. 3 over 5, that means when it's squared, 3 over 5, 9 over 25. Yeah, so the angle is decreasing, the 3 over 20 radian per sec. And when you are uh, in a balloon, you can sit down the bicycle and yeah, let's see. We want to find the rate of a change in this distance from the balloon to the bicycle. Do you know there is an accident in the submersible down to the Titanic? I mean, do you know the news? Yeah, so I mean, I hope they are okay. I mean, it's terrible. I mean, oh, there is still time, so I hope they are to be found. Yeah, so balloon is rising. Okay, so dy over dt is 1 feet per sec. Yeah, so the bicycle speed is 17 feet per sec. So after 3 seconds, what will be the value of this horizontal distance? 17 times 3 is. Can you multiply 17 and 3? Yep. Yeah, 51. So the horizontal distance is 51. So let's first make this the Pythagorean equation. And if we differentiate this, I already cancel these twos. Okay, so x is 51. Ah, now I see what this means. Okay, and uh, at the point after 3 seconds later, the y value is because the y's speed is 1. I mean, you can multiply 1 and 3 and add it to 65. So what will be the value of y when x value is 51? Mm, because 1 times 3 is 3, I just add 3 and 65. Yep. And then, so we can find the value of s at the moment. Yes, the value is kind. Ah, okay. Ah, now I see. Okay, so because 68 is 17 times 4, 51 is 17 times 3. So that means that s will be 17 times 5. So 85. Yep, so if we use these values, 51 dx over dt is 17, y is 68, di over dt is 1. Oh, yeah, now we can find the value of ds over dt. We need to use calculator for this. Let's see. Okay, okay, now I see what I'm going to do. We can cancel this. So 11. Yeah, so the distance is increasing. The 11 feet per sec in this case. And in this problem, the cardiac output is measured in this equation. Yeah, so if we differentiate this equation, in this case the Q is constant, so if we differentiate this, dy over dt is Q constant, so it's like, yeah, we have this equation. Mm, and the value of Q is 233. D is 41 square, and dd over dt is decreasing at the rate of 2 units, so that means this is minus 2. So if we find this value, the value is about 277. I mean, it's 0 point 277. And the sign is positive, that means the cardiac output is increasing. So this D means difference, and the difference between the carbon dioxide concentration. So if the D is decreasing, and that means a gas exchange does not occur efficiently. So that's why the heart cardiac output is increasing. So it becomes more heart get more burden. So in number 27, um, yeah, so let's differentiate this parabola equation. That means dy over dt is, yeah, what is derivative of x squared? Can you find derivative of x squared? Yeah, 2x and dx over dt. So dx over dt is 10 in this problem, and we wanna find the angle. Okay. Yep. So when x is 3, what's the y value? Because y is x squared. When x is 3, y is yep, 3 3 squared is 9. And then the angle. Angle in this case means tangent theta. Tangent theta is y over x. Yep, so if we differentiate this equation, tangent derivative is secant squared. And in this case, we can use the quotient rule. Quotient rule means denominator is squared, and it's similar to product rule, but we subtract. And then because dy over dt is 2x times dx over dt, if we change dy over dt here, no, no. And y is x squared. So x squared cancel, so it's like dx over dt. So that means d theta over dt is equal to cosine squared theta. So if we make the right triangle, when x is 3 and y is 9, yeah, what's the length of hypotenuse in this right triangle? Yeah, length of hypotenuse, this one. You're right. Yep, so that means 3 times square root of 10. So what's the value of cosine theta in this right triangle? Tell me the fraction. Which over which? Yep, so 1 over square root of 10. So squared means 1 over 10. And dx over dt is 10. So that means the angle increases with a rate of 1 radian per sec in this case. Let's think of another graph. Once again, we want to find the rate of change in the angle. So if we make the square of the given equation, y squared is minus x. So if we differentiate this equation, x coordinate decreases at the rate of 8 because the particle moves from right to left. That's why x coordinate decreases. So dx over dt is minus 8. So that means this is a positive 8. And from the equation, what's the value of y when x is minus 4? Can you find value of y when x is minus 4? Yeah, 2, right? Square root of 4 is 2. So y is 2. Y is 2. That means this 2y is 4. Oh, yeah, let's see. So we are putting minus 2 in place of x like this, right? X is, yeah, that's why it's positive and 2. Yep, so y is 2, so 2y is 4. And actually, we don't have to use this equation. I mean, because we want to find this once again this d theta over dt. Let's just see. So once again, yeah, tangent theta is mm, yep, and then so when x is minus 4, y is 2. So 16, x is minus 4. Ah, I see. So using this equation, because 4 times dy over dt is 8, at this moment dy over dt is 2. Okay, so x is minus 4, dy over dt is 2, y is 2, dx over dt is minus 8. Okay, so 1 over 2. Okay, so d theta over dt. So let's find out the value of cosine theta when x is minus 4 and y is 2. Yep, what's the length of a hypotenuse in this right triangle? Can you find the length of a hypotenuse? Yep, yep, so 2 times square root of 5. Yep, so what's the value of what value of cosine theta in this triangle? Yeah, yeah, yep, like this. And when it's squared, it becomes positive. So that means, so the rate is 2/5, and it's increasing. Let me think again. Yeah. The meaning of increasing in this case. So if we make the equation, and if we make the graph of this equation, and when x is going this direction, yeah, I should say the angle is increasing. Even it's going away. Yeah. Yeah, and a moving shadow. So we are going to make two triangles, similar triangles, like this. Man is 6 feet tall, and the straight line height is 16 feet. So, tip of the shadow. So this is the length of the shadow, and let's say this one is the distance from the man to the straight line, and the total distance is let's say d. So because these two triangles are similar, we can make some proportion. 6 over L is equal to 16 over L plus X. And then, so if we make cross multiplication, so this means L is length of shadow is 3/5 of the distance between the man and the light. So first, let's find out the rate of change in the length of shadow. So if we differentiate this equation, and okay, and the dx over dt in this case -5 because it's decreasing. The man walks toward the straight line, so x should be decreasing. So that means if dx over dt is minus, but this is -3. Am I right? Um, yeah. So the length of a shadow will be decreasing with a rate of 3%. Am I right? Yeah. And then if we want to find the rate of tip of the shadow, that means we want to find um, this dd over dt. This is the second d here. One second. At first, d is equal to l plus x. So if we differentiate this equation, dd over dt is because these two values are both the negative, the tip of the shadow is moving toward the straight line with a rate of 8 feet per second. And in number 31, if a ball is dropped, uh, we can also find the a change in the length of shadow in this case. Because the ball is in free fall, we use the equation in free fall. The s is 16 times t squared. So if the falling distance is s, this is 50 minus s. Okay, so we wanna find this dx over dt. Okay. So let's make the proportion using these similar triangles. So if we make the cross multiplication, So 50x cancel. So that means the product of S and X is constant of 1500. So if we differentiate this equation, this is 0. So half a second later, according to this equation, when t is 1/2, what's the value of s? Can you find value of s when t is 1/2? Uh, are you? Yep, 16. Yep, find value of s. T is 1/2. One half second later, so t is 1/2. And what's the falling distance? Yeah, 4. Yep, so s is 4. When s is 4, according to this equation, x is this 1500 divided by 4. Okay. Okay, okay. Yep, so s is 4. Okay. And then, yep, we can differentiate this equation, the pre-fall equation. So that means ds over dt is, yep, can you differentiate this one? 16 times t squared, what's the derivative of 16 times t squared? Yeah, can you, yep, differentiate this one? Yeah, 32t. And because t is 1/2 at the moment, ds over dt is 16. So when this is 16, that's 4. Okay. So this means dx over dt is, okay, 4 minus 1500 feet per sec. Yeah, so quite fast. When ball is dropping down, the shadow become really fast, and it's decreasing because it's toward the shadow length is decreasing. I don't think we have to put negative sign here because it's asking just how fast. Yep, so I think that's it for today. So let's keep doing this next week and do your homework and send me the file. So yes, so, tomorrow we are going to meet at 7, right? Because you wanna have some time. So yeah, at 7. Yeah, let's meet tomorrow for AMC. Yeah. Mm. Have a good day. Yeah, bye.